Today's lesson is on solving systems of equations by substitution. Sometimes we're not given a grid to graph. So remember in the last notes, we were graphing systems by graphing it. Or sometimes, sometimes we're not given a graph, or sometimes it's very difficult to graph. So when stuff like this happens, there's actually two other methods to solve the system. Today we're going to be focusing on one of those options. So that option is going to be solving by substitution. There's 5 steps to it, and it sounds like a lot of steps, but honestly, like once you get the hang of it, like it becomes kind of natural. Okay. So step number 1, we're going to solve for either the x variable or the y variable on either equation. As long as I can get either the x by itself or the y by itself on either equation, then that's what we're going to try to aim for. We're going to try to pick whichever one's easiest. Okay. And you'll see what I mean by that as we start doing these problems. Once we have one of those variables solved, now we're going to go ahead and isolate the variable, which is already done. We're going to substitute what we just found, right, whichever one we got, into the other equation. Once we have it substituted into the other equation, we're going to solve for the remaining variable. That's going to give you the first half of the answer. So you're either going to get like an x equals a number or a y equals a number in most cases. Once you get that number, you're going to use your first answer and you're going to substitute it back into either equation. Doesn't matter which one. And we're going to get the second half of the answer. Once we're done with that, then we're going to go ahead and write our answer as an x comma y pair, and we will be done. All right, so we'll go through those steps because I know it was a lot that I said. I promise you it's not as complicated as it sounds, but I mean, you need to have kind of that information out there somewhere. So it says use the substitution method to solve the system. Y equals 3x minus 1 and 2x plus y equals 4. Remember, what we did before was we would graph it. We're not going to do that. We're going to use these 5 steps, and we're going to solve by substitution. So step number 1, we're going to get one of the variables by itself. Either the x equals or a y equals. That's going to be our first step. Well, check this out. Like in this case, I already have one of them by itself. I already have this y completely by itself. It says y equals something. So step number 1 is done. I've already solved for one of the variables. In this case, I solved for y. Now, step 2 says, now that I have isolated the variable, I want to substitute what I just found into the other equation. So they just told me that y equals 3x minus 1. That means anywhere I see a y in the other equation, I get to replace it right here. Instead of writing that y on the bottom that I highlighted in pink, I get to replace it with its other value, which is 3x minus 1. So that's exactly what we're going to do. We're going to rewrite that second equation. Instead of 2x plus y equals 4, I'm going to write 2x plus, there's my y, right? But I'm not going to write y. I get to replace it with its other value, which is going to be 3x minus 1. Sometimes you're going to need to write that in parentheses. Oh, and don't forget to write the equals 4. Sometimes you need to write it in parentheses. If there's something attached to the y, then you need to put it in parentheses. But because it's just plus y, I can just replace it with plus 3x minus 1. All right, so step 2 is done. I've isolated the variable, and I don't know why it blanked out like that. That's kind of weird. Give me a second. Let me see if I can fix this. Okay, I got it working. I don't know what happened, but it's working now. Okay, so now that we have it set up, we're just going to go ahead and start solving, right? We just did step 2, which was we replace it into the other equation. Step 3 is solve for the variable. So notice that now, because I replaced the y with x's, there's only x's left, and I can go ahead and solve this pretty easily. I can combine like terms, which means I have 5x minus 1 is equal to 4. There's only x's on one side, so I can start undoing what's being done to the x. Right now I have a 5x and it's being subtracted by 1, so I get to add 1 to each side. I get 5x is equal to 5, and then divide both sides by 5. And I get x equals 1. Hey, at this point, I found the value of x. I know that x is equal to 1. I get to take that x, and I'm going to step 4. This is, let me read step 3 again. Solve for the variable. I just did that. This is going to give me the first half of the answer. So the first half of my answer is x equals 1. I got one of the halves. The other part is step 4, use the first answer and substitute it back into either equation to get the second half of your answer. So I'm going to take that x equals 1, And I can either plug it in here into this x, or I can plug it in here into this x. It really doesn't matter because the answer is going to be the same regardless of which one you plugged it into. You're going to plug it into the easier one, which in this case is going to be the top equation. Okay, let me go ahead and plug it into my top equation. I'm going to write, so we're going to go ahead and replace it. I'm going to use the first one. Let me go ahead and write that. This is going to be y equals 3 times 1, because I'm replacing it. You see that x right there? I'm replacing it with the 1 value that I just found. Okay, so y equals 3 times 1, and I still need to write minus 1. So y equals 3 minus 1, and so therefore y equals 2. All right, I got the second part of my answer. Now I just need to write my answer. So step 4, use your first answer, substitute it back into the either equation. You get your second half of my answer. I got my second half is right there. And then step 5, I'm going to write my answer as a coordinate. So we need to write this as x comma y, which remember that my x value that I found was 1, and my y value that I found was 2. So 1 comma 2 is my solution to this system. If we were to kind of go back to it, what I'm trying to tell you is if I graph both those equations like we did yesterday, then they're going to cross each other at the coordinate 1 comma 2. That's where they're going to intersect each other. And that's it. All right. Okay, so let's take a look at letter B, and let's see if we can kind of build off of what we just learned. We're going to go through the steps again. Step 1 is to solve for either the x variable or the y variable, whichever one's easiest. Hey, again, they did it for me. I don't have to worry about it. Look, I got y equals something. In this case, y equals 3x minus 6. So in the other equation, wherever I see the letter y, I get to replace it with the other thing. In this case, the 3x minus 6. So right here, instead of writing y, I'm going to write 3x minus 6 because I'm just kind of sticking it in there. Okay. So what do I write? I write 3x minus 6 is equal to, and then the rest of it, which is going to be x plus 2. So I'm done with step 1. I solved for y. I'm done with step 2. Well, I'm almost done with step 2. I substituted it in, and now I need to solve for the remaining variable. In this case, I need to get x. Notice I have x's on both sides. So I need to get rid of the smaller x, which means I'm going to get rid of the x on the right by subtracting x's on both sides. These are going to cancel. I'm left with 2x minus 6 is equal to 2. Now that I have x's on one side, I'm just going to go ahead and add 6, since right now it's being subtracted. I get 2x is equal to 8, and then divide both sides by 2. I get x equals 4. What did I just do? I isolated, I substituted, I found my other equation. Step 3, solve the variable. I did that. This will give me the first half of the answer. So the first half of my answer is x equals 4. Now I'm on step 4. I'm going to use the first answer, remember my x equals 4, and I'm going to substitute it back into either equation. It does not matter whether you substitute that x equals 4 into this one, or if you substitute the x equals 4 into this one. Well, because the bottom one looks so much easier, I'm going to replace it right here. So I'm going to write y equals, and instead of x, I get to write 4 plus 2. Let me go ahead and write that. Y equals 4 plus 2. That is me substituting my x value right there. Well, that's easy. That just means y equals 6. And I'm going to go ahead and write. So step 4 is done. I got my second half of my answer. I know the second half is going to be 6. Now I just need to write it as an ordered pair, which was x comma y, which in this case is going to be 4 comma 6. And this is the solution to my system. All right, hopefully that made sense and I can go a little bit quicker. Let's see, on this one, oh, maybe not so quick just because this one looks a little bit tougher. Let me go ahead and see. I got x minus y is equal to 5. Y plus 5 is equal to negative 4x. And I want you to notice that in no way, shape, or form did I have a variable completely by itself. This thing has a negative 4 on the x. It's not by itself. So I'm actually, and this just comes with experience, I'm actually going to solve for this x. Step one, get one of your variables. It doesn't matter which one. I'm going to get this x by itself just because to me it looks like the easiest to get by itself. So let me go ahead and rewrite this. In fact, let me do this kind of on the side. If I have x minus y is equal to 5, then to get x by itself, I need to add y to both sides. And I get x equals y plus 5. Okay. Hey, I just got x by itself. Step one is done. I got x completely by itself. I know anywhere I see an x, I can replace it with y plus 5 on the other equation. Anywhere I see an x, I can replace it with y plus 5. So here's an x on the other equation. I get to replace that x with y plus 5. So let me go ahead and write the full equation. That says y plus 5 on the left is equal to -4. There's my x. You see how there's right next to the x, there's a number? Since right next to the x, there's a number, I'm going to replace that with a parentheses. And in the parentheses, I get to write the y plus 5. I didn't do that in the other case because there was nothing stuck next to the x or the other variable. This time there has a number stuck to it. You need to put it in parentheses. All right, so I'm done with that step. I'm going to go ahead and solve for the remaining variable, which in this case, I'm going to solve for y. Remember that when you have something like this, you need to distribute that -4. You're distributing the entire -4, so this is still y plus 5 is equal to -4 times y is -4y. -4 times 5 is a -20. Now that I've distributed, I'm going to get rid of the smaller variable. In this case, it's the smaller y. I'm going to get rid of that -4y. I can get rid of the -4y by adding 4y in each side. These are going to cancel. I'm left with 5y plus 5 is equal to -20. Subtract 5 from each side. 5y is equal to -25. I believe we already did the hard part, guys. Divide both sides by 5. Y equals -5. So far, and I know this was kind of tough, but we did find the first part of my equation. I know that y is equal to -5. I get to take that y equals to -5 and I get to replace it either on the first part or on the second part. It does not matter whether you substitute it into this y or this y. I'm going to go ahead and substitute it into that first one. When you do that, I'm going to write x minus, and here's my y. What am I going to write instead of y? I get to write -5. So in parentheses, I'm going to write -5, just because there's something in front of it, is equal to 5. Well, I have a minus -5. I hope you understand that I have that minus here, and then my y is -5. That's why I have a minus thing going on right there. And I know when I have a minus, I really should change that into a plus. So this is x plus 5 is equal to 5. I'm going to get rid of that plus 5 by subtracting 5 on each side. I get x equals 0. So I got both parts of my answer now. I got my first part and my second part. Remember, we need to write this as x comma y. My x is 0 and my y is -5. So my answer should be 0 comma -5. Okay, I'm going to speed it up a little bit. Let's see. I got x equals 2y minus 3 and then 8 equals 4y minus 2x. It looks like I have one of my x's by itself, so they save me some work. That's great. Anywhere I see an x on the other equation, I get to replace it with 2y minus 3. I see my x right here. That's where I'm going to replace it with 2y minus 3. So I get to write 8 equals 4y minus 2 times, there's my x. Because it's stuck with the 2, I'm going to put a parentheses right next to it, 2y minus 3. Remember that when we do stuff like this, 8 equals 4y, I need to distribute all of this, which means I need to take this -2 and distribute it here and here. Don't just distribute the 2, distribute the -2. That's going to give me a -4y plus a 6. Let's see, I got y's over here. I can combine like terms. 4y minus 4y, that's 0. That's 8 equals 0 plus 6. That means 8 equals 6. Whoa. Whoa. We've seen stuff like this before. Do not get confused. I got a statement that says 8 equals 6, and 8 definitely is not equal to 6. Therefore, this is going to be no solution. What does that mean? That means these lines are never going to cross each other. What does that mean? That means those lines are parallel, right? You've done stuff like that before, so please don't get confused. It's not anything super crazy. All right, we're on to letter E. It says 1 equals x minus 3y, and then 3 equals negative y plus 3x. To me, it looks like the easiest one to get to by itself is going to be that x. So let me rewrite this. I have 1 equals x minus 3y, and I'm going to get that x by itself. So let me add 3y to both sides. When I do that, these are going to cancel, and I get 1 plus 3y is equal to x. I have solved for the letter x. Anywhere I see the letter x on the other equation, I get to replace it with 1 plus 3y. On the other equation, I see an x right here, so I know that's where I'm going to write the 1 plus 3y. So let me rewrite this entire equation again, but replace that x with this value now. So this is going to say 3 is equal to negative 9y plus 3 times, what's my x? My x is 1 plus 3y. I'm going to go ahead and distribute that 3. Because it's a positive, I really don't need to distribute the positive. 3 equals negative 9y plus 3 times 1 is 3. 3 times 3y is a positive 9y. I'm going to go ahead and combine like terms. It looks like that negative 9y with the plus 9y, that's going to give me 0. So 3 is equal to 0 plus 3. Or 3 is equal to 3. Again, I'm getting one of those weird statements, but they said 3 equals 3. That's a true statement. That means that this is always going to work. So I'm going to say that there is an infinite number of solutions. Hey, before we used to say like all real numbers, but we got to be careful when we're dealing with ordered pairs. What this is really telling you is if I were to graph it, right? What they're saying is something like the lines are always touching each other. They're always intersecting with each other. The way that would look like is like, let's say, here's my first line, like this. Well, here's another line, like this. You see how those lines are always touching? Like they're literally right on top of each other. So they're always intersecting. So it's going to intersect here. It's going to intersect here. It's going to intersect here. It's going to intersect all over the place. So there's going to be an infinite number of solutions. Now, the reason you can't say all real numbers is because even though they're constantly touching each other and there's like an infinite number of points, this point right here doesn't work because it's not on either line. It's not on the first line. It's not on the second line. This is on both lines. This is on both lines. This is on both lines. But this dot over here, it's not on both lines. So we can't say all real numbers. That's not necessarily true. All right, we're chugging along here. We're going to have 2 more problems, and then we're going to be done. We got a couple word problems. It says cakes cost $20 and donuts cost $3. You buy 4 items and spend $46. How many of each did you buy? Unfortunately, with these word problems, we're going to have to set up equations. So let's go ahead and start by doing that. Cakes cost $20. Well, what is it we're trying to find? We're trying to find how many cakes and how many donuts, and we don't know either, right? So I'm going to say, let's see, represent the number of cakes. And let D represent the number of donuts. We're going to come up with equations. Well, let's see. If I spent $20 per cake, and I don't know how many cakes I bought, and $3 per donut, and I don't know how many donuts I bought, but I do know that I spent $46 total, then what I can write is 20C plus 3D equals $46 total. This is going to be my money equation. This represents how much money was spent. So for example, if I bought 2 cakes, that's 20 times 2. If I bought 3 cakes, that's 20 times 3. Okay. The other equation they said is that I bought 4 items. Well, how many cakes did I buy? I don't know. I bought C of them. And then plus, how many donuts did I buy? Well, I don't know. I bought D of them. But I do know that if I add the number of cakes plus the number of donuts, there's 4 items total. This is the items formula. Now that I have both equations set up, I'm going to go ahead and use my substitution. I need to solve for one of the variables, so let me solve for c in this case. I got c plus d equals 4. If I subtract c on each, you know what? No. If I subtract d on each side, because I said I was going to solve for d, I'm sorry, I was going to solve for c. These are going to cancel, and I get c equals negative d plus 4. So I'm going to take that c, and I'm going to substitute it into my other equation. Anywhere I see a c, it gets replaced. So when I write this one, it's going to say 20 times my c, which is negative d plus 4, plus 3d equals 46. Let me go ahead and write that right now. That is 20 times my c, which is negative d plus 4, plus 3d equals 46. I'm going to distribute that 20. That gives me negative 20d plus 80 plus 3d equals 46. Combine like terms, I get to combine the negative 20d with the 3d. That should give me a negative 17d plus 80 equals 46. Subtract 80 on each side. Negative 17d is equal to negative 34. Divide both sides by negative 17, and I get d equals 2. What did I just find out? I just found out that the number of donuts that I bought was 2. We're going to go ahead and plug that 2 into either the first equation or the second equation. I'm definitely going to use the second equation because the second equation is much easier. So I'm going to write c plus 2. I know d equals 2, so I'm going to substitute it right here. So c plus 2 equals 4. Well, I mean, that must mean that c is equal to 2. Remember what these represented. C was the number of cakes, so I must have bought 2 cakes. And D was the number of donuts, so we must have bought 2 donuts. So we get to say I purchased 2 cakes and 2 donuts. And guys, you could check your work just to make sure that this actually worked, right? Like if you bought 2 cakes, that's $40. If you bought 2 donuts, that's $6. 40 plus 6, that's $46. That works. And then you said that you bought 4 items total. 2 plus 2, that's 4 items. And so sure enough, it works. Okay. All right, we're down to our last problem. It says, example, you've tried 7 milk teas and tried 5 new ones each month. Your friend has only tried 1, but she tries 8 new flavors each month. How many months before she has tried all the amount of flavors? Well, what are they asking you for? They're asking for the number of months. That means we don't know how many months. So I'm going to say let M represent the number of months. And what else are we talking about? Well, we're talking about the amount of flavors tried. So I'm going to say let F represent the number of flavors tried. All right, this one's a little bit different. So let's see. You've tried 7 milk tea flavors and try 5 new ones each month. So if I'm going to make an equation just for me, it looks like I already have a head start. Like I've already done 7, but I'm doing 5 each month. So that 5 needs that variable attached to it because it's 5 months and then another or 5 flavors and another 5 flavors and another. It looks like I'm counting by 5s. Okay. So if I want to find out how many flavors I've had, I'm going to say F, the number of flavors, is equal to, well, I'm doing 5 flavors a month plus the 7 that I already started off with. Okay. This is for how many flavors I've done. So this is for me. As far as for my friend, it said that they've only tried 1 so far, but she tries 8 new flavors every month. So after 1 month, it's 8 more, and then another 8 more. So it looks like they're counting by 8s. So I'm going to write the number of flavors for my friend. They're counting by 8s, so I'm going to put the M next to the 8. And they started already with 1 flavor, and this is for my friend. Now that I have my two formulas set up, I can go ahead and start using substitution. I'm going to go ahead and highlight that I already have my f isolated. Anywhere I see an f on the other equation, I get to replace it with 5m plus 7. Well, here's my f. That f on the bottom, I'm going to write 5m plus 7 in its place. So let me go ahead and start doing that. So I write 5m plus 7 is equal to 8m plus 1. Looks like I can't combine like terms, but I do have a smaller m, so I'm going to get rid of the smaller m. I'm going to subtract 5m on each side. These are going to cancel. I'm left with 7 equals 3m plus 1. I thought I did it wrong, guys. Sorry. And we're just going to solve. So let's see. Let's get rid of the plus 1 by subtracting 1. 6 is equal to 3m. Divide both sides by 3. 2 is equal to m. What did I just find out? I found my m is equal to 2. Remember that m represented the number of months. I forgot the question. Let's read the question again. How many months before each has tried the same amount of flavors? Do I know how many months? Yeah, it's 2. It's written down there, right? I could go back and plug it in, but they're not asking me how many flavors have they tried. So I'm actually done right here. I can go ahead and stop and say it will take 2 months to try the same amount of flavors. And we can check this out, right? Like we can check our answer just to make sure that we're saying something that's true. If it's 2 months for me, then that would be 5 times 2 is 10. 10 plus 7, that means I would have tried 17 flavors. And if it's 2 months for my friend, that'd be 8 times 2, which is 16, plus 1, that's 17 flavors for my friend. So 17 flavors for me, 17 flavors for my friend. After 2 months, it looks like my math is working out. All right, guys, that's all that we have for today. As always, if you have any questions, please feel free to ask.